Hey, College Trig. I got my glasses today. My eyes are really bothering me. Week 7. Just one more week left after this. I promise you, week 8 is going to be pretty short for you. We're missing a whole unit on conic sections. We're going to try to do it quickly, and we're going to try to do it as easy as possible. What are conic sections? Conic sections are, well, if you were to take a cone, and you were to just slice off the top of it, just take a cross section, you come out with a circle. If you were to take a cone and you were to slice it, say like this, okay, this section right here, if you were to turn it and look at it, it would make the shape of a parabola. So conic sections, the root word is cone. So what happens when you section a cone? Now, suppose you didn't cut it parallel to there, but rather you took this cone and you cut it like that. Well, this portion right here, as you were to look at it, you would definitely get an elliptical type shape as you look at that. And finally, the last one, if you were to stack two cones on top of each other and you were to slice it like that, you kind of have a somewhat of a parabola on this side and somewhat of a parabola on that side. That'll make what we call a hyperbola shape. These are parts of cones, and we're going to look at the graphs. One thing that makes them unique is in the equation, a circle has an x squared and a y squared. A parabola just has one or the other, not both. An ellipse also has an x squared and y squared, and the fact is that they have different coefficients. So they have different values in front of the x squared and y squared for an ellipse. And they're both positive. The x squared and y squared are both positive, just like in a circle. But a hyperbola has an x squared and y squared, but one of those values is negative. And so we're going to go through those and kind of lay out how to graph them and whatnot. So let's look at the first one. We've got x squared plus y squared is 25. Now I see an x squared and a y squared. They're the same values. They are both positive. That makes a circle. The radius in that case is equal to 5, and the center is, in this case, 0, 0. So you would just simply make a graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and you sketch it like that, okay? Now, I have a PDF of your assignment, and then I also have a Google Doc. Just simply take that PDF, either print it off or do the problems on a separate sheet of paper, and then just take pictures and paste it right in that Google Doc for your submission. That's our first example, okay? Example 1 would be our circle. We're going to do another circle that doesn't have a center at 0, 0. So that'll be example 2. And this one looks like this. X squared plus y squared plus 2x minus 4y is equal to 4. So when I look at this, I can tell that it's going to be a circle because it's got two squares and they both have the same coefficient, 1. Whereas an ellipse has both squares and positives, but it would have different coefficients. So I can tell this is a circle. And I'm going to need to complete the square. X squared plus 2x plus y squared minus 4y, that all is equal to 4. What do you add to complete the square there? Well, you take that number 2, you divide it in half to get 1, and you square it to get 1. So I add 1 to the other side. Negative 4 divided by 2 is negative 2. Squared is 4. I add a 4 there, add a 4 there. So we have x plus 1 squared, y minus 2 squared is equal to, that's a 9. Now, what's cool about this is we have the center of negative 1, positive 2, and the radius of 3. So as you make this graph, we simply go back 1, we go up 2, that's our center, and then from there we go 3 units in each direction, okay? 3 units, 3 units, 3 units, and 3 units. You can, make a quick sketch there. It doesn't have to be super exact, and that's circles. So in just 5 minutes, we've gone through circles, and now we're going to take you through parabolas. So 2 that you're very familiar with, and then we'll do 1 that you're not, okay? Or 2 that you're not. So our first video will be for the parabolas and the circles. Parabola. X is equal to negative 1 over 8y squared. That was a little bit new for you. If you notice in this situation, it's x equals and not y equals. What you're used to is something like this. Y equals negative 1/8 x squared. And you would say, oh, well, that's centered at 0, 0, and it goes down. Okay? Well, when it switches, when it's x equals, it becomes a horizontal one. So in this case, it has a number of properties. First of all, we say it has a vertex. It has a direction. It has an axis of symmetry. It has what we call a focus point. And then finally, it has what we call length of a lattice rectum. Length of a lattice rectum. So that's how far it's stretched apart. It's a segment that tells you how far it's stretched apart. We're going to show you what that is, okay? So first thing I notice is since it's x equals, it's horizontal. It either goes to the right or to the left. Because it's negative, it's going to head in the left direction. Okay. Just a y squared, there's nothing added on, so our vertex is 0, 0. Okay. I'm going to start making that sketch. I'm going to plot right there. Okay. And it's going to head off this direction. Okay, if it heads off this direction, then the axis of symmetry is y is equal to 0. Y is equal to 0. Now, the focus and the length of the lattice rectum, that's what we need in order to really sketch the rest of our graph. Okay, and it's not too terribly difficult to come up with. What you do is you take the number in front of the square and you set it equal to 1 over 4p. P becomes a very important value in determining the focus point and the length of the lattice rectum. That will tell us how wide to make the parabola. So, in this situation, I cross multiply. I get 8 is equal to negative 4p. I divide by negative 4, and I get negative 2 is equal to p. Negative 2. What that means is, in order to find my focus point, I go that many units along the axis of symmetry. So I'm going to go 1, 2 units right there. And that's what we call my focus. That's the vertex. That's the focus. So because it's horizontal, okay, and it's negative, I moved 2 units that way. Okay? So the focus location is negative 2, 0. The length of the lattice rectum is simply the absolute value of 4 times p. So if you take 4 times p, you get negative 8. Absolute value is 8. And what that means is it's stretched 8 units. So if I go 4 in this direction and I go 4 in this direction, right through my focus point, I draw that segment. And that tells me how wide to make this parabola. So from this vertex, now I know how wide to make that parabola. Okay? So I know that that was new learning. We're going to try another example so you can kind of hone it in and hopefully it'll make more sense, but those are the pieces that we're looking for. Do example 4 here, then we'll go ahead and get to our next video. So we have the equation x squared minus y minus 4x is equal to 0. Okay? Now, we know that that's a parabola because you only have one thing being squared. Only one thing is being squared, not x squared and y squared. I'm going to solve, since the x is being squared, the x's are going to go on the right, and then the y will just be on the left. So I have to kind of complete this square here to put it in the right form. So I have negative y is equal to negative x squared plus 4x. Now what you can do is you can go ahead and multiply through by negative 1. Y is equal to x squared minus 4x. We need to complete the square. So y is equal to x squared minus 4x. So what we are going to do is we're going to add a 4 there. Now remember, adding 4 to one side is the same as subtracting 4 from that same side. So we have y is equal to x minus 2 quantity squared minus 4. And that's the completed square of my parabola. Okay, that's my completed square of my parabola. I'm going to give myself some space here. Well, maybe I can make it. We'll see. So it's a y equals, so it goes up and down. Since it's positive, it goes up. The vertex is going to be 2, negative 4. So over 2 and down 1, 2, 3, 4 units. Okay? Over 2, down 4. Axis of symmetry divides it right in half. It's vertical, so the axis of symmetry is going to look like that. Or x is equal to 2. So all we need to do that's really new for us is to determine this p-value. I take the number that sits in front of the squared, which is 1, and set it equal to 1 over 4p. If I cross multiply, I get 4p is equal to 1, so p is 1/4. What that tells me is I move a fourth of a unit in the direction, so it's up, so I'm going to move a fourth of a unit up. So I was at 2, negative 4, so if I move up a fourth, I'm going to be at 2, negative 3, 3/4. Okay? The length of the lattice rectum is the absolute value of 4p. Well, if you take 4 times that, you get 1. And the absolute value of 1 is 1. That means that how far do I stretch this thing? 1 unit. So if you go a half a unit to the left and a half a unit to the right, that segment represents how wide you make your parabola. And there you have it. I know that that's not super easy. It is definitely new to you. The idea of this focus, this length of lattice rectum. I really took what we did during this unit. I divided it about into a third. So I just want to get the bare essentials in. This is definitely the more challenging lesson for the next 2 weeks. So week 8 is going to be pretty straightforward. No problems at all. Ellipses and hyperbolas, I think, are easier than the parabolas. I think the parabolas are the most challenging. So if you need to rewatch that, so be it. But we'll see you in the next video.